Hello students, welcome to aimsindia online classes. This is a chemistry session. Here we are discussing about chemical bonding chapter. So in this session we are going to see about multiple bonds and polar bonds, polar and non-polar bonds. So we are going to discuss about this. First let us say about multiple bond formation. The covalent bond formed by the sharing of more than one pair of electrons between two atoms is called multiple bond. Generally, two atoms when they approach each other, both the atoms contribute one electron and hence they share a pair of electrons. Then the bond formed is called normally covalent bond. Sometimes two atoms they may share more than one pair of electrons. Then the bond formed by the sharing of more than one pair of electrons between two atoms is called multiple bond. If the covalent bond is formed by the sharing of two pairs of electrons between two atoms, then it is called double bond. See here, when two atoms approach each other, this atom contributing two electrons and the other atom also contributing two electrons. Totally they are sharing two pairs of electrons between these two. In this way, the covalent bond formed by the sharing of two pairs of electrons between two atoms is called a double bond. Okay, let us see an example. That is the formation of oxygen molecule. We know each oxygen atom contributes two electrons and two pairs of electrons are shared equally between the two oxygen atoms. Both the atoms acquire octet configuration of nearest noble gas neon by this. See here, suppose if it is an oxygen atom, it has 6 valence electrons. And in the same way other oxygen atom also has 6 valence electrons. When these two approach each other, each oxygen atom contributing two electrons and they are sharing two pairs of electrons and hence both are becoming stable by acquiring nearest noble gas neon configuration. See here, this oxygen atom after sharing it is getting 8 electrons in its valence shell. At the same time, this oxygen is also getting 8 electrons in its valence shell by sharing of two pairs of electrons. Hence the bond formed between these two is called a multiple covalent bond or double bond. This also can be represented like this. O double bond O. Okay. Another type of multiple bond. If the covalent bond is formed by the sharing of three pairs of electrons between two atoms. Yes, sometimes two atoms may they share three pairs of electrons also. Then the covalent bond formed between those two atoms is called triple bond. Let us see an example for this also. For example, the formation of nitrogen molecule let us consider. We know nitrogen atom has 5 valence electrons because atomic number is 7 and its configuration will be 2, 5. When two nitrogen atoms approach each other, both the nitrogen atoms contribute 3 electrons from each and hence they share 3 pairs of electrons and thus they form 3 covalent bonds between two nitrogen atoms. So here each nitrogen has 5 valence electrons. When these two approach, each nitrogen contributing 3 electrons for covalent bond formation. In that way, they share totally 3 pairs of electrons. By that they get nearest noble gas neon configuration. It is getting octet. It is also getting octet configuration by the bond formation. And hence, they are forming 3 covalent bonds between those two atoms. These 3 together called as a triple bond. Okay, this also can be represented like this. Nitrogen triple bond with nitrogen. Okay, these two are considered as multiple bonds. The covalent bond formed by the sharing of more than one pair of electrons between two atoms is called a multiple bond. If two pairs of electrons are shared, it is called double bond. If three pairs of electrons are shared between two atoms, then it is called a triple bond. Now let us see another concept that is bond pairs and lone pairs of electrons. Have a look at the Lewis dot structure of oxygen molecule to understand this. See, this is oxygen molecule. There are two oxygen atoms in the molecule which are bonded by two pairs of electrons sharing. that is double bond. Now, in this molecule, there are 6 pairs of electrons totally from the valence shells of both the oxygen atoms, isn't it? They are numbered like this. This is one pair of electrons, 2, 3, 4, 5, 6. Totally 6 pairs of electrons are there on both the nitrogen atoms together in this molecule. Now, out of these 6 pairs of electrons, if you observe the fifth pair, this is and this pair of electrons, these 2 pairs of electrons are involved in the covalent bond formation between the atoms. So like this, the pair of electrons which are participating in the bond formation are called as bond pairs. Okay, now we can say the fifth and the sixth pairs of electrons, fifth and sixth pairs of electrons are called bond pairs because they are participate in the bond formation. And if you observe the remaining all, these pairs of electrons are also 1, 2, 3, 4, also present in the valence shells of these two atoms, but they are not involved in the bond formation. Such pairs of electrons which are present in the valence shells of these participating atoms, but they are not involved in the bond formation, are called as lone pairs of electrons. Okay, those 4 pairs are called lone pairs of electrons. Did you get it? The pairs of electrons which are present in the valence shell of an atom, and if they are participating in the bond formation, then they are called bond pair of electrons. If they do not participate in the bond formation, then they are called lone pair of electrons. Okay, thus we can define like those. The pair of electrons, the shared pair of electrons, which results in the formation of a bond, is called bond pair of electrons. If we see water molecule, here also there are totally 4 pairs of electrons. Out of this, here and here, 2 pairs of electrons are there which are participating in the bond formation. These are called bond pairs of electrons. And the pair of electrons present in the valence shell but not involved in the bonding is called lone pair of electrons or non-bonded pair of electrons. Here, in this water molecule, there are 2 pairs of electrons on the oxygen in the valence shell which are not participating in the bond formation. They are called non-bonding pair or lone pair of electrons. Okay, that's about a lone pair of electrons and bonded pair of electrons. Next, one more concept let us see here. Violation of octet. Yes, actually the elements they participate in the bond formation for getting octet configuration in their valence shell, and thus they become stable like noble gases. Isn't it? For this purpose only all the elements they will try to participate in the bond formation and hence they acquire octet configuration. But in certain molecules, some atoms, even though they participate in the bond formation, they do not get octet configuration. Means some atoms sometimes they get more than 8 electrons in the valence shell after bond formation, and some elements they get less number of electrons than octet even after bond formation. Those conditions are called as violations of octet rule, means not following octet rule. In some molecules, atoms attain more or less electrons than octet. Let us see one example. Consider the formation of PCl5 molecule. In the PCl5, phosphorus is central atom and it has 5 valence electrons, isn't it? So when it is bonded to the 5 chlorines, it shares 5 pairs of electrons out of those, one with each chlorine atom, and thus it forms 5 covalent bonds. See the diagram here. Phosphorus is having 5 valence electrons and it is sharing one pair of electron each with 5 chlorine atoms, and thus it is forming 5 covalent bonds. So after the covalent bond formation, if we observe total number of valence electrons for phosphorus, already there are 5 electrons, it is shared 5 more electrons. Total it gets 10 electrons in its valence shell. But according to octet, how many electrons should be there in the valence shell to become stable? Only 8. But it gets 10 electrons after the bond formation in PCl5 molecule. That is called superoctet, getting more than 8 electrons after bond formation on its central atom is called superoctet. Now we can say PCl5 is a superoctet molecule. Did you get it? Here Some more molecules are mentioned which are having superoctet on their central atom. If you see SF6, in the similar way just like PCl5, there also sulfur has 6 valence electrons. It is sharing one pair of electrons each with 6 fluorine atoms. Thus, it forms 6 covalent bonds. So in that way, after the bond formation, sulfur, central atom sulfur is getting totally 12 electrons in its valence shell by sharing of 6 pairs of electrons. But it is more than octet. It is more than 8 electrons. In that way, this molecule is called superoctet molecule. So in that way, it is a violating octet rule. See some other molecules also. Xenon difluoride, xenon tetrafluoride, iodine heptafluoride. In these all molecules, central atoms are having more than 8 electrons after the bond formation. These are called superoctets. Okay. Another way. Similarly, consider the formation of another molecule, BeCl2, beryllium chloride it is called. In this molecule, beryllium is central atom which has 2 valence electrons because atomic number is 4. Its configuration is 2, 2. So there are 2 valence electrons. It combines with the 2 chlorine atoms. Beryllium shares 2 pairs of electrons, one with each chlorine atom, and forms 2 covalent bonds. Okay. Beryllium shares a pair of electron with one chlorine each. In that way, it shares totally 2 pairs of electrons. Thus, after the bond formation, also beryllium is getting only 4 electrons in its valence shell in the BeCl2 molecule. Isn't it? Observe here, already for beryllium there are 2 electrons. It is sharing 2 more electrons, one from each chlorine. And thus, it is getting only 4 electrons. This is called deficiency of octet. Okay, it's called deficiency of octet. Let us see here some other examples for the molecules which are having deficiency of octet on their central atom. One example is BF3, boron trifluoride it is called. In this central atom is boron which is having only 3 valence electrons. So after forming 3 covalent bonds with 3 fluorine atoms, it gets 3 pairs of electrons shared. That means only 6 electrons. But according to octet, there should be 8 electrons. But boron is having only 6 electrons in its valence shell in BF3 molecule. This is called deficiency of octet. Even after bond formation also, it is not getting 8 electrons. Okay, in the similar way, aluminum chloride molecule also. Right, that is about violation of octet rule, having superoctet or deficiency of octet. Okay, now let us see another concept, that is polar covalent bonds and non-polar covalent bonds. Have you ever watched children playing together with a toy? Yes, we might have observed sometimes they equally share the toys, and some other times one child will take the other child's toys away, isn't it? You might have observed this. Some types of chemical bondings are also very similar to the way that children play with the toys. Let us see what are those. First, let us see one of the kinds of those bonds is non-polar covalent bond. The covalent bond between two similar atoms or the atoms with the same electronegativity is known as non-polar covalent bond. It is also defined as the covalent bond in which bonded pair of electrons is equally shared between the two atoms is known as non-polar covalent bond. So if two atoms, we know in the covalent bond formation, each atom contributes one electron, and thus both the atoms they share this pair of electrons, and hence a covalent bond is formed. If the shared pair of electron is equally shared between the two atoms, then the covalent bond formed is called non-polar covalent bond. Let us see an example. For example, in the homoatomic molecules means the molecule formed between same atoms, same kind of atoms, or atoms of same element. For example, if you say hydrogen molecule, in hydrogen molecule, each hydrogen atom contributes one electron. for covalent bond formation, and thus both the hydrogen atoms, they share a pair of electrons. Here both are hydrogen atoms. Both will be having same electronegativity. That means the tendency of pulling electrons will be same for both these atoms, and thus the pair of electrons are equally shared between these two atoms, equally attached by both the atoms. Thus, there will be no moment of electron pair towards one of those atoms. They will be exactly at the middle. Such kind of bonds, such kind of covalent bonds, in which the pair of electrons are equally shared between two atoms, is called non-polar covalent bond. Okay, thus the bond formed so-called non-polar covalent bond. Okay, simply to say, the covalent bond formed between two atoms in which pair of electrons are equally shared by both the atoms is called covalent bond. But to say definitionally, the covalent bond which is formed between the two atoms which are having electronegativity 0 is called a non-polar covalent bond. Let us see another type of covalent bond. Polar covalent bond. The covalent bond formed between two dissimilar atoms. That means atoms of different elements, or atoms with different electronegativities, both represent the same. So if two atoms with the different electronegativities, if they participate in the covalent bond formation, then what happens? The pair of electrons are not equally shared between two atoms. One of those two atoms, that means the atom with more electronegativity, will pull the pair of electrons towards it. Thus the covalent bond formed is called polar covalent bond. It is also defined as the covalent bond in which bonded pair of electrons is unequally shared between two atoms, is called polar covalent bond. So here two atoms, they are contributing one electron for bonding. Then they share a pair of electrons. But out of these two, one atom is having higher electronegativity. Because of high electronegativity, instead of sharing this pair of electrons mutually, this will pull the pair of electrons towards it. So what happens by pulling the pair of electrons along with its own electron, one more electron is coming towards it, isn't it? We know by gaining of electrons, atoms they acquire negative charge. So here also it is acquiring one electron, so it gets negative charge. But here it is not completely taking, just it is pulling the pair of electrons towards it a little instead of being equal. So because of that, it acquires a slight negative charge. It is represented like this. At the same time, if you see this atom, it is losing slowly its electron towards a strong element. By losing electrons, elements will get a positive charge, we know. But here it is not completely losing, just it is moving towards other element. That's why it also gets slightly positive charge. In this way, two slight poles or charged poles are created in this molecule. Pole represents charged end. So two charged ends are created in this molecule because of unequal sharing of pair of electrons. So that is why these molecules are called polar molecule. Okay, let us understand this more by taking one example. For example, in the heteroatomic molecules, heteroatomic means molecule formed with different atoms, atoms of different elements like HCl, HF, H2O, NH3, etc. Let us consider HCl molecule. So here chlorine and hydrogen both will contribute one electron for covalent bond formation. Thus they share a pair of electrons. But here chlorine is more electronegative than hydrogen. Because of its more electronegativity, instead of sharing this pair of electrons equally, it pulls the pair of electrons towards it. See here, it is not shared equally. It is towards mostly chlorine. So because of that, chlorine will get slight negative charge. At the same time, hydrogen will get slightly positive charge. In this way, slight polarity is created in this molecule. Thus, the molecule formed is called polar covalent molecule, and that compound is called polar covalent compound. Okay, the resultant covalent bond becomes polar covalent bond, and that compound is called polar covalent bond. Did you understand? If the electron pair is equally shared, then the covalent bond is called non-polar covalent bond. Non-polar means no formation of polarity or charges because there is no pulling. If the electron pair is equally shared, thus there is no formation of charge. Thus the molecule is called non-polar molecule. If the electron pair is pulled towards one of those two atoms, then the resultant molecule is called polar covalent molecule. Okay, that's about polar and non-polar molecules. Okay, thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates and recorded videos.